Hey guys, what's up? Today we're gonna continue with what we ended with last lecture, and obviously we didn't solve this question. We did not differentiate sin x or any trigonometric function because we needed some basic formulas of trigonometry, which we will discuss first. Well, the basic trigonometric function, the first one includes like sine of a plus b. So where we have a as an angle and a b angle, and a plus b is also angle, so because dimensions are same. So the formula is given by, in this case, is given by sine of a into cos of b plus sine of b into cos of a. So that is the formula of sine of a plus b. Then comes sine of minus a minus b. This can be therefore derived by putting b equal to minus b. And when sine comes, like if there is sine of, let's say, minus x, then that is equal to minus sine x. Sorry with that. It is minus sine x, and if there is cos of minus x, then we have equal to cos x. That is, the negative sign does not come out. So we can use that here in this condition here. We can use that formula here, and we'll get, when we put minus b here, cos b will remain cos b. So we'll get sine of a into cos of b. So we get the first term, and then when I put right here, when I put minus b, we get a minus outside, and thus we end up with sine of minus sine of b into cos of a. So that is the formula of sine of a minus b. Right. Now similarly we have cos of a plus b. When we talk about cos of a plus b, cos of a plus b, so there is a small difference between these two, that like there are two differences between these two. In the first one, as we saw that in sine a plus b, we have alternate terms. Like if we have, in a term we have the multiplication of a sine and a cos, whereas in the cosine formulas we have a term in which the same products are available, and also when there is cos of a plus b, there is a negative sign involved. That is, let me write the expansion, then we'll understand. So the expansion here is cos of a into cos of b minus sine of a into sine of b. Right. So that is the expansion of cos of a plus b. Now you can see that first of all, same terms, same operations are there. Cos is there in the first term and sine is in the second term. And secondly, there is a negative sign here. So that is cos of a plus b. Similarly, you can now put minus b and check out what is cos of a minus b. Now let us continue with the differentiation of y equal to sine x. Now when we solve this question, we know we need to use the first principle. Now let us write the first principle. It is dy by dx is equal to limit h tends to 0 f of x plus h minus f of x over h. Right. So this is the first principle. Now let us put the values here, or the function here. So limit h tends to 0 sine of x plus h minus sine x over h. Now I apply the sine formula here. So I'll get limit h tends to 0 sine of x into cos of h, right, plus cos of x into sine of h, right. minus sin x. So that is the formula, divided by h. Now let us just take these two common here, that sin x common here, and we divide it into two parts. The first one being limit, limit h tends to 0, sin x is common, cos h minus 1 over h, right? And here we have plus cos x into sin h over h. Now one more thing, just as I told you that there is a thing like product rule, right? We heard about the product rule, which is like if there is limit x tends to 0 and f of x into g of x, then that is equal to limit x tends to 0 f of x and into limit x tends to 0 g of x. Similarly is the case with all other operations. You can apply that in all other operations, like if you have addition, like limit, we have limit x tends to a, f of x plus g of x, right? Then I can write that as equal to limit x tends to a, f of x plus limit x tends to a, g of x. And you can similarly put negative and positive. When it comes to division, like if it is limit x tends to a, f of x over g of x, then this can be written so this cannot be written in the form of limit above and below, because this is a quotient rule, right? You cannot apply this here. So similarly we can now use a addition rule here. We can divide it into two parts. Like what I do, I write limit h tends to 0 here also. So I can say that I have done the addition rule here. So now let us first consider this one, which is a quite easy one. In here we have this part, sin h upon h. Now sin h upon h tends to 0 is what we call as the sin x upon x limit, and that is equal to 1. So what we are left by now, we have one limit, that is limit h tends to 0 sin x into cos h minus 1 over h, and right here we have cos x. Now if you remember that we have done this limit, and this limit is equal to 0, so I can say that I can cancel out this limit, and we are at end left with cos x. So that is the derivative of sin x. So the derivative of sin x with respect to x is equal to cos x. Now similarly have a table in which I have noted all these sin x, and this is the table. Here first of all is dc by dx. Now c is a constant like 2, 3, 4 etc. So that is always equal to 0, because it will never change. That we need to find the rate of change, and it will never change. Now secondly is d upon dx of mx, and it is to be noted that m is a constant, so it will come out, it will become dx upon dx. So if you consider it to be a fraction, we can cancel out dx and dx, and thus it will come out to be m, and so is it. So the differentiation of a straight line is its slope, right? We need to learn that. Now third is dc is x square upon dx. Similarly we put c outside, and then the differentiation of x square is 2x. Then we have d of x to the power n upon dx, which is m x to the power n minus 1, which can prove by binomial theorem. Then we have d of e to the power x upon dx, which is e to the power x. Then we have d of ln of x, which is d by dx of ln of x, which is 1 by x. Then the derivative of sin x, which is proved to be cos x. Similarly, if we find the derivative of cos x using the cosine formula, we will get minus sin x, right? Also here we have d of tan x upon dx, which uses a extreme kind of product rule, as well as tan x for proportion, but you need to learn that derivative comes out to be secant square x, right? Then it is d of cot square x, which is minus cosecant square x. Then we have d upon dx of secant x, which is secant x into tan x, and d of cosecant x, which is minus cosecant x into tan x. So I can say that these are important to learn. Not all these are important to learn because these are mostly used, and the rest of it can be derived using the first principle. So they need not to be learned, or you can also derive it using other differentiation rules too, which we will discuss in our later chapters. So that's it. So just learn these small differentiation formulas only. These are just for our help only. This will come a lot of help whatever you think in maths, physics, chemistry, whatever you want. So that's it. Thank you.